My name is Ennia and I am a PhD student in Automotive for Intelligent Mobility at the University of Bologna. My research deals with driving behavior, specifically the impact of the smart road and also the advanced driver assistance systems called ADAS on the road safety. The focus of the study falls within the preliminary analysis of the road safety, considering the driving and visual behavior, the three on-site tests, the evaluation of the new systems called ADAS, in particular the adaptive cruise control, and finally the description of a specific infrastructural element of the smart road that is an innovative pedestrian crossing. Three important on-site tests were conducted. The first concerns the relationship between driver and vehicle, including the influence of the adaptive cruise control. The test 2 deals with the driver-road interaction. Finally, the test 3 describes the interaction between drivers and the innovative pedestrian crossing. The aims of the tests are the analysis of driving, visual, and vulnerable road users' behavior. The first test is localized in the Tangenziale of Bologna. Thanks to the use of the VBox tool that allows monitoring the kinematic parameters of the vehicle, it was possible to record the influence of the adaptive cruise control. In fact, this system emits electromagnetic waves that localize the previous vehicle in the same lane. The vehicle automatically adjusts the speed by setting a minimum distance. When the vehicle finds the clear lane again, the ACC increases the speed up to the set limit. In case of queues, the ACC manages to decelerate the vehicle until it stops completely. To test the driver-road interaction along the Foglienza Street in Tavuglia, it was used the mobile eye tracker. This tool is designed to monitor the movements of the pupil with the spectral-mounted unit. This element consists of two cameras mounted on special glasses. One is focused on the eyes and one on the external environment. The output is the video with the red cross, as we can see, which represents the point of view of the drivers. In the test 3, it was analyzed the innovative pedestrian crossing located in Via Andrea Costa. It consists of bright LEDs inserted in the sidewalk, a sign indicating the crossing, and a light pole, in addition to the public lighting. The monitoring system is composed by one video camera for each direction of travel. The result of the test 1 allowed describing the driving behavior. It consists of the perception reaction time, the average speed, and the average minimum distance between cars. The first graph in particular shows the trend of the speed and the acceleration. In this way, it was possible to underline the range of the perception reaction time. In fact, it starts with the yellow line when the user observes the previous vehicle braking. It is possible to identify this yellow line thanks to the use of the mobile eye tracker. And the red line, which represents the end of the PRT, establish the time when the test vehicle brakes. When the ACC is turned on, the PRT is greater for both ACC user and no user, as we can see in the graph below. The average speed shows either value with the system on for both types of users, while the minimum distance is greater with the ACC active. The visual behavior of the second test is connected with the percentage of attention. This element was extrapolated by the count of the frames recording during the video, establishing two macro categories, the attention and the inattention. The attention in this case is either respect of the inattention, and it is specifically connected with the category of street and cars. The vulnerable road user's behavior underlines that the braking distance is measured when the system is active, and the vertical sign is the first element seen in the pedestrian crossing. The graphs shows also the average of crossing, considering the months of July and August, and all a single day, to establish a precise trend in these two different times. The conclusions highlight that for the first test, the comparison between manual and autonomous driving underline that there is a decreasing in terms of perception reaction time when the system is disabled. For the second test, the structure of the self-explaining route is effective because the subjects show an high attention. The most seen categories for the attention are cars and street and roads, instead of the inattention with the background. Also, in the third test, the system installed in the pedestrian crossing is effective for the road safety because the distance of braking increases when the system is turned on. Thank you for your attention.